So guys, this is our second video in our mole revision series. Now I've divided it into 3 parts because I want to take my time with you. I don't want to rush about it. Now in the first part, that was an introduction to the mole. But in the second and third part, this is whereby we are going to do pure calculations on the mole. Now our first question. In a reaction, 20 cubic centimeters of 0.1 molar sodium carbonate completely reacted with 13 cubic centimeters of dilute sulfuric acid. Find the molarity of the acid used. Now, when I get such a question, actually any question, I like to write down the information in a way that makes sense to me. So we have sodium carbonate over there reacting with sulfuric acid. What do we know about sodium carbonate? We know its volume. We also know its molarity. 20 cubic centimeters in a molarity of 0.1. So this reacts with sulfuric acid, whose volume is 13 cubic centimeters. Do we know its molarity? No, we don't. That is what we need to find out. So this reaction leads to the formation of sodium sulfate, water, and carbon 4 oxide. Now guys, when you are given such a question, the first step that you need to do is write a balanced chemical equation, because from the equation, you're going to use the mole ratio to obtain a certain answer. So in this equation, we can clearly see that it's already balanced. We have 1 mole of sodium carbonate reacting with 1 mole of sulfuric acid to form 1 mole of sodium sulfate, water, and carbon 4 oxide. So what is our starting point going to be? Those are the steps we're going to carry out. Determining the number of moles of sodium carbonate, determining the number of moles of the acid, sulfuric acid. Lastly, we are going to determine the molarity of the acid used. First step, determining the number of moles of sodium carbonate. Now we can easily do so because we have the volume and we also have the molarity, and we are going to use this formula. Moles is given by molarity multiplied by volume over 1000. 20 by 0.1 over 1000 gives us the number of moles of sodium carbonate as 0.002 moles. Good. On to step 2, determining the number of moles of sulfuric acid using the mole ratio. Now, in case you're wondering, why are we using the mole ratio? Why can't we just directly calculate the number of moles of the acid? Guys, what do we know of the acid? We literally know only the volume, which is 13 cubic centimeters, nothing else. So the information that we have is insufficient. It's not enough for us to take the direct route. So that is the reason why we needed to calculate the moles of sodium carbonate first and then use the mole ratio to obtain the moles of the acid. Now look at the equation. 1 mole of sodium carbonate reacts with 1 mole of sulfuric acid. So if the actual number of moles of sodium carbonate was 0.002 moles, then those are going to be the same number of moles of the acid. Our last step, determining the molarity of the acid. Now, at this point, what do we know of sulfuric acid? We know its volume. We also know the moles. So we can use this formula to calculate the molarity. Molarity is given by moles over volume multiplied by 1000. 0.002 over 13 cubic centimeters multiplied by 1000 gives us the molarity as 0.1538 m. And guys, it's a capital M standing for molarity. So guys, this was our first question. How do you feel after it? Good? Let us continue then. So our second question, 10.08 grams of ethanedioic acid crystals with that formula were dissolved in water and made to 1 decimeter cubed solution. 25 cubic centimeters of this solution was completely neutralized by 20 cubic centimeters of 0.2 molar sodium hydroxide solution. Calculate the molarity of the acid, and part B, the value of X in the acid. Okay, now guys, by the way, I forgot to mention this. The reason why you are seeing a dot and then X H2O is because this is a hydrated salt. It has water of crystallization. Now we need to find out how many moles of water of crystallization is present in 1 molecule of the acid. Okay, let's talk about ethanedioic acid. So this is simply another name for an acid called oxalic acid. You might have heard of it. I think this is the more common name. Oxalic acid, ethanedioic acid, same thing. Now, According to the question, we are being told that this acid with a mass of 10.08 grams was dissolved in water. By the way, I would like to say this. If you need to process the information or take down, the calculations, just pause the video and do so. So this was dissolved in water and then made up to a solution that was 1 decimeter cubed. So 1 decimeter cubed is a volume that is equivalent to 1,000 cubic centimeters, also equivalent to 1 liter. So these three have the same volume. So out of this 1,000 cubic centimeters, 25 cubic centimeters of this solution was used in a reaction with sodium hydroxide. Essentially, this is a neutralization reaction. We are having a reaction between an acid and a base. Now, this reacted with sodium hydroxide. What do we know of sodium hydroxide? We know its volume. We also know its molarity, 20 cubic centimeters of volume and a molarity of 0.2. What about the ethanedioic acid? Okay, the one that reacted, we only know its volume, and that is 25 cubic centimeters, nothing else. So these two react with one another, leading to the formation of a salt, of course, and water, because this is a neutralization reaction. So in order for us to calculate the molarity of the ethanedioic solution, we are going to need to find the number of moles first, and this is where the mole ratio comes in. Now, for us to use the mole ratio, we need to have a balanced chemical equation of the reaction between these two. So there we have it. So these two, an acid and a base, react, leading to the formation of a salt, which is termed as sodium oxalate. Now, in case you're wondering, hey, where's this formula coming from? Let me make it all clear for you. So sodium hydroxide, when in solution, dissociates to form two ions, positively charged sodium ions and negatively charged hydroxide ions. The same thing happens to the ethanedioic solution. It dissociates to form positively charged hydrogen ions and the oxalate ions. These are negatively charged. Now, I want you to make a note of the hydrogen ions. All acids have replaceable hydrogen ions, but the number differs from one acid to another. Nitric acid and hydrochloric acid have only one replaceable hydrogen ion, and these are termed as monobasic acid. Sulfuric acid, on the other hand, has two replaceable hydrogen ions, and that is why it's referred to as a dibasic acid. Now, ethanedioic acid is also a dibasic acid. So these are terms that you're going to need to be familiar with in such questions, in questions of molarity. So in this case, what is going to be formed is the salt. So when an acid reacts with another compound, it's usually the hydrogen ions that are displaced, that are pushed out. And you're going to have a cation replacing the hydrogen ions. A cation is a positively charged ion. So it displaces the hydrogen ions. Which cation do we have here? The sodium ions, of course. So sodium ions will combine with the oxalate ions. Positively charged ions, negatively charged ions, and you get a salt which is neutral. What is the valency of sodium ions? 1. What is the valency of oxalate ions? 2. When these interchange, you get a salt that has that formula. Now, if we balance our equation, we get a mole ratio of 1:2. 1 mole of ethanedioic acid reacts with 2 moles of sodium hydroxide. There we have it. Now, we are ready to start with the actual question. Yeah, it was just an introduction, guys, okay? Yeah. So what are the steps that you're going to carry out? Number 1 is that we are going to calculate the number of moles of sodium hydroxide, because this is the reagent that has more information as compared to ethanedioic acid. So the steps that we are going to carry out are as follows. Number 1, determine the number of moles of sodium hydroxide. Number 2, determine the number of moles of ethanedioic acid solution using the mole ratio. And lastly, determine the molarity of the acid. So let us start. How are we going to determine the moles of sodium hydroxide? By using this formula. Do we have the molarity? Oh, yes, we do. What about the volume? So we are going to multiply these two, divide by 1,000, giving us the number of moles as 0.004 moles. Next step, the number of moles of the acid. So what is our mole ratio? 1:2. So if the actual number of moles of sodium hydroxide are 0.004 moles, that means the number of moles of ethanedioic acid solution will be half of that. 0.002 moles. Last step, determining the molarity of the acid. What do we have at this point regarding the acid? We have the moles, which we've just calculated. We have the volume, which is 25. So bandika kila kitu, and this gives us a molarity of 0.08 m. That is the molarity of the acid. So we have answered part A. Let us now tackle part B. Now in part B, we are being told that we need to find the value of X in ethanedioic acid. As stated before, this is a hydrated salt. It has water of crystallization. So we need to find the number of moles of the water of crystallization. That is essentially what X is. So what are we going to do? So we need to calculate the molar mass to tujue what X is. And we are going to do that by using this formula. Molarity is given by mass in grams per liter over the molar mass. Do we know the molarity? Yes. Do we know the mass in grams per liter? Yes, we do. Look at the first part of the question. 10.08 grams were dissolved in 1 decimeter cubed, which as stated before is equivalent to 1 liter. So we can easily find the molar mass. So the molar mass is given by the mass in grams per liter over the molarity. 10.08 over 0.08. This gives us a molar mass of 126 grams. What is the molar mass? This essentially is the mass of 1 mole of ethanedioic acid, including that of water of crystallization. So for us to determine the mass of the water of crystallization, we are going to take the whole, which is 126, and subtract the mass of that part. So let's start with the RAM of hydrogen. Hydrogen has the RAM of, how many do we have? 2. Carbon RAM of 12, we have 2. Oxygen RAM of 16, we have 4. If you sum all of these, you're going to end up having 90 grams. And 90 grams is the molar mass of this part. So 126 minus 90 gives us 36 as the molar mass of the water molecules present. But guys, what is the molar mass of 1 molecule of water? 18. Where did 18 come from? 16 from oxygen, and hydrogen is 1 by 2. So 16 plus 2 gives us 18. So the mass of 1 molecule of water is 18 grams. But we're being told that it's 36. That means we have 2 molecules of water. And therefore the value of X is 2. There you go. Okay, let me give you a few seconds to breathe before we continue with the next question. Okay guys, let's continue with our next question. This is a bit easier, so it's going to give us time to breathe. So calculate the number of water molecules when 34.8 grams of hydrated sodium carbonate with that formula is heated and 15.9 grams of anhydrous sodium carbonate is obtained. Okay, so we have the RAMs of the following elements. Now, when you have a hydrated salt, such as in this case, when you heat it, what happens is that the water of crystallization evaporates due to heating, of course. Now, because water of crystallization is lost, you're going to have a decrease in mass. So at the beginning, we had 34.8 grams of hydrated sodium carbonate, but at the end, it decreased to 15.9 grams. Why did it decrease? Due to the loss of water of crystallization. So if we were to find the difference between these two values, we are going to get the mass of the water of crystallization, which is 18.9 grams. Now, if you have a question on a hydrated salt and it's asking you for the formula, you need to have a table such as that. So you're going to place your sodium carbonate and water as a block. Mass, molar mass, moles, and mole ratio. Fill in the relevant details. The mass of sodium carbonate is 15.9, mass of water 18.9. Moving on to the molar mass. So for us to obtain the molar mass of these two compounds, what is going to happen is that we are going to take the relative atomic masses of each individual element, sum them up. So in the case of sodium carbonate, RAM of sodium is 23. How many do we have? 2. Carbon is 1, 12. Oxygen is 16. But how many do we have? 3. So if you sum these up, you're going to get the molar mass of sodium carbonate. And this is 106. Moving on to water, we have 2 hydrogen atoms, 1. Every hydrogen atom has an RAM of 1. So 1 by 2 plus 16 gives us 18. Next, determining the moles of each. We are going to use this formula. Moles is given by mass over molar mass. Our mass is 15.9 over the molar mass 106. So the number of moles of sodium carbonate was 0.15. Same goes for water. Mass over molar mass. And this gives us 1.05. Now moving on to our last step, the mole ratio. So in the mole ratio, what you're going to do is we're going to take a look at these two values, 0.15 and 1.05. Which is the smaller value? 0.15, of course. We are going to divide these two values by 0.15. So of course, in the first case, 0.15 divided by itself gives you 1. In the case of water, we get 7. And that is our answer. We have 7 molecules of water. Moving on to our next question. In a titration experiment, 25 cubic centimeters of a solution of sodium hydroxide containing 8 grams per liter was required for complete neutralization of 0.245 grams of a dibasic acid. Calculate the relative formula mass of the acid. Okay. So what is going to be our first step? Kama kawaida, we are going to write a balanced chemical equation. Now in this case, we have sodium hydroxide reacting with the dibasic acid. What do we know of sodium hydroxide? That 8 grams were dissolved in 1,000 cubic centimeters, but in this solution of 1,000 cubic centimeters, only 25 cubic centimeters was used. What about the dibasic acid? We know very little about it. So as you can clearly see, it's written as H2XYX because we don't know what this is. We've just been told it's a dibasic acid. Do you remember a dibasic acid? It contains 2 replaceable hydrogen ions. So it's H2X, whatever X will be. Now this leads to the formation of a salt, Na2X plus water. In case you're thinking, hey, Na2X, where is this coming from? Let me make this clear for you by using sulfuric acid, which is an actual dibasic acid. So in this reaction, we have sodium hydroxide reacting with sulfuric acid to form sodium sulfate plus water. According to this, the reason why sulfuric acid has 2 hydrogen atoms is because the 2 comes from the valency of the sulfate atoms. So hydrogen ions have a valency of 1. Sulfate ions have a valency of 2. When these interchange, ile 2 ya sulfate inaenda kwa hydrogen. And the same thing happens with sodium sulfate. So sodium has a valency of 1. Sulfate ions have a valency of 2. When these interchange, you end up having Na2SO4. Now coming back to our equation, H2X, U2 ni valency ya X. So if you're going to form a new compound, sodium X, the sodium is going to have its valency of 1 kama kawaida, and the X is going to have a valency of 2. When these interchange, 2 inaenda wapi? Kwa sodium. So that is why we end up having this formula. Now this is very important. You need to get it right because this will determine how you balance the chemical equation, which in turn will determine the mole ratio. So balancing gives us that, and a mole ratio of 2 is to 1. So 2 moles of sodium hydroxide react with 1 mole of the acid. So what information do we know about the acid? We know that it has a mass of 0.245 grams. So can we calculate the RFM of the acid just by using this? Of course not. We need to find the number of moles first. And how are we going to do that? By using the following steps. Number 1, determine the molarity of sodium hydroxide. Number 2, determine the number of moles of sodium hydroxide. Number 3, determine the number of moles of the acid using the mole ratio. And lastly, determining the RFM of the acid. Now let us start. Let's look at the information that we've been provided with regarding sodium hydroxide. Your acid yeke kando, like literally we have very little. So in the case of sodium hydroxide, we have the volume, yes. What else do we have? You know, the mass that was initially dissolved. Can we use these two to calculate the number of moles of sodium hydroxide? Unfortunately not. But we can use these to calculate the molarity of sodium hydroxide and then use this to calculate the number of moles. So we are going to use this formula. Molarity is given by mass in grams per liter over the molar mass. How many grams of sodium hydroxide were dissolved in 1 liter? 8. Remember, 1 liter is equivalent to 1,000 cubic centimeters. What is the molar mass of sodium hydroxide? You're going to take the RM of the elements. That 23 plus 16 plus 1 gives us 40. So tunabandika everything. And what do we end up having? We end up having 8 over 40 gives us 0.2 m. Now moving on to our next step, determining the number of moles of sodium hydroxide. So at this point, we have the volume, we have the molarity, which we just calculated, and we can easily find the number of moles using this formula. So molarity multiplied by volume over 1000. Our molarity is 0.2. The volume is 25 over 1000, gives us the number of moles of sodium hydroxide as 0.005 moles. Lastly, second last, the moles of the acid. So we are now going to use our mole ratio. What is our mole ratio? 2:1. So if the actual number of moles of sodium hydroxide are 0.005 moles, the number of the acid is going to be half of that. We just cross multiplied, and this gives us the answer as 0.0025 moles. We are almost at the end, guys. Almost. Our last step, determining the RFM of the acid. So at this point, what do we know of the acid? We know the mass, 0.245 grams. We also know the number of moles. And we can use the most basic formula of all to calculate the RFM. So the molar mass, which is what we are after, is given by the mass over the moles. So 0.245 over 0.0025 will give us the molar mass of 98 grams. So the RFM of the acid is 98. And by the way, guys, this is actually the RFM of sulfuric acid. And this, ladies and gentlemen, brings us to the end of this jam-packed lesson. Yani, mumeiva ama bado? If the answer is yes, then good for you. If the answer is no, then I've got your back. We have another video that is going to be released tomorrow, whereby I'm going to be tackling more questions on the mole. Yani guys, kama umemaliza these 3 parts of the mole, you shouldn't have any issue with the calculations. So thank you for keeping me company, and I'll see you tomorrow on the 3rd part of the series.